day 2 for standard algorithm multiplication. So now we're taking a look at multiplying a 3-digit or 2-digit number by another 2-digit number. So it adds a little bit of a degree of difficulty. So I want you to make sure that you're paying attention. We're going to make a connection to partial products to see how it's really the same thing, but you can still make that decision what's going to work best for you. So let's look at that first problem that I had you taking a look at. So 489 times 38, okay? We'll take a look at partial products. So we would go through 8 times 9 is 72. Then I work my way through. I have to do 8 times all of these numbers. We've had lots of people who were trying to skip and say, I did 8 times something and then stop. No, you got to do 8 times these 3 things. So now I'm left with 8 times 80. That would be 640. And 8 times 4, that would be 3,200. Okay, now I move on to the 30 times things. All right, 30 times 9 is going to be 270. 30 times 80, that's what, 2,400. And 30 times 400, that's going to be 12,000. Now, if you're looking at it and wondering why I'm going so fast or how I'm going so fast, practice. That's how. I've practiced this. I've done this hundreds upon hundreds upon hundreds of times. I'm not expecting you to ever have to go that fast through these problems, but I'm trying to get to the standard algorithm. That's the new part for us today. So I went quickly through this part. Now, when we do the standard algorithm, I'm going to have a lot of this exact same steps. My first step is still to do 8 times 9. That was my first step in partial products. 8 times 9 is 72. So my ones number is coming down, but I'm carrying the 7. 8 times 8 is 64, plus the 7 that's there. 64 plus that 7 makes 71. So my 1 goes here, and I carry a 7. And then 8 times 4, that'd be 32, plus the 7 there makes 39. Now, here's where things get different. And I do one thing that other people don't. Once I've done the 8 times all 3 numbers, I'm going to get rid of these. I'm going to cross them out so I don't accidentally use them one more time. You'll see what I mean in a second. But it's a good idea when you're doing multiplying by 2 or 3 digits or however many digits. Once you're done with all this stuff that we've carried over, get rid of it. You don't want to mess it up and accidentally add it in one more time. Now I've got to deal with this 30 over here, this 3. Now, before, we could just worry about the fact that whatever digit it was. I didn't have to worry about this being 80 and this being 400. This is the only time I need to start off worrying about place value. This is 3 tens, okay? No matter how many groups of 3 tens I have, I will never end up with a 1. Because every time I add 3 more tens, I'm not going to get any 1s. Because of that, I will not get any 1s when I'm multiplying by 30, okay? So I'm going to put this 0 there before I get started. Some people will call it a placeholder. It's going to keep me from filling in this place. I don't want any 1s when I'm multiplying by tens. I can't get to it. So now when I multiply, I don't really have to worry about it anymore. I only had to worry about place value when I put this in. Now I can just do my 3 times 9. 3 times 9 is 27. 7 goes here, and I carry the 2 over. Now I'm doing 3 times 8. 3 times 8 is 24, plus the 2. Not 7, that's crossed out, plus 2. So that's 26. Put the 6 down, carry the 2. Notice I always just carry it to the next spot. If I was multiplying by the 8, my number that I carry over goes over to the next place value spot, over that way. Okay, now I have 3 times 4 is 12, plus the 2 there makes 14. All right, now I do have to add. I have these 2 sets. So when I add them, 2, 8, 5, carry the 1, 8, 1. 1, 2, 3 digits, 18,582. Over here, just to make sure that I came out the same both ways, I get 2. Let's see, it's 14, 18. Carry the 1. That's 7, 9, 11, 15. Carry the 1 again. 4, 6, 8, and 1. Either way, I'm ending up with the exact same number. The difference is, over here, I'm way more concerned about place value because I'm rewriting these so many times, but I do have it much more spaced out so I can see things a little bit clearer. But then I do have all of these things to add up, and if they're misaligned, I have something wrong. Over here, there's lots of possibilities for mistakes. If I don't cross these off, I could have added the 7s in an extra time. I could add something wrong or carry it over and put it in the wrong spot. So you just really need to make sure that you're going through things slowly. I can go through it very quickly because after doing it a million times, I have a very set sequence that I know this is the way it's going to go. The more you practice, the more you'll be able to just do it without thinking about what's the next step. Okay. So it may take you a while to get there. You may have to stop and go much slower and think about what's the next step? What's the next step instead of moving so quickly. All right, we're going to take a look at one more standard algorithm multiplication. Okay. I'm not going to do a 4-digit problem though. So we'll do a 3-digit problem, 829 times, I don't know, let's do 6 because we've had problems with those facts too. Now, the reason I'm not doing a 4-digit one, it's not your standard in 5th grade. We needed to be able to do 3 digits times 2 digits. And in all honesty, once you can do 3 digits times 2 digits, which speaking of that, 2 digits, once you can do that, then really it doesn't matter. I can keep adding digits down here. It follows the same pattern. So once you know how to do this, everything follows the exact same pattern, no matter how many digits there are. So let's try this out. Here we go. We start with our 1 spot, always. Adding, subtracting, multiplying. We always start over here. Okay, so I'm going to do my 6 times my 9. 6 times 9 is 54. My 4 drops down, and I carry the 5. 6 times 2, next spot over. 6 times 2 is 12, plus 5 makes 17. 7, carry the 1. Now 6 times 8. 6 times 8 is 48, plus the 1 that's there is 49. All right, now I'm going to add some. Oh, I'm done with the 6s. Let's get rid of those numbers. Now I'm going to add something, okay? I'm multiplying by 5 tens. When I'm multiplying by groups of tens, I can't end up with 1s. So long, 1s. Okay, so now I don't have to worry about it. Everything's going to go and be in tens or higher. So 5 times 9 is going to be 45. So there's my 5, carry the 4. 5 times 2 is 10, plus the 4 that's there makes 14. Carry that 1. And 5 times 8 is 40, plus 1 makes 41. Adding these together, I end up with 4. That's 12, 10, 14, 1, 5, 6, and 4. So I end up with 46,424. Very large number. Basically what it comes down to is just knowing the basic steps for this. And for the love of God, if you don't know your multiplication facts, start practicing them. This is not going to go away. You have to know your multiplication facts. So hopefully these make sense. Do some practice. If it's not coming out right, then please come stop off at office hours and ask for help. This also, the standard algorithm, is something your parents might actually be able to help you with. This is probably the way they learn too. It's the way I learned it, so they are probably very familiar with this. So this is an area where parents can actually really help out because it's the traditional method that they're used to. So if you can't get a hold of us for some reason, mom, dad, grandma, aunt, uncle probably know this pattern. They may not have known partial products or area model, but I bet they do know this one. All right. So hopefully this helps, and we'll see you during office hours. Bye.